Welcome everyone and thank you for attending this session. My name is Dennis Torres. I'll be talking about going to Azure SQL, admin difference no one told you before. So I'll be talking about some specific difference between managing an Azure SQL, especially an Azure SQL database, where we don't have full access to the instance, and managing an on-premise SQL Server. So we'll talk about some difference between this management. I'm a database and BI administrator. I'm also a data platform MVP trainer with some Microsoft certifications. I'm the Malta Data Platform User Group Leader. Feel free to get in touch. You have the page of our user group, my contacts on the side. It will be a pleasure to connect. Feel free to get in touch and ask me anything you would like. So, what we will talk about today? I'll talk about integrated authentication on Azure SQL database, some database options, especially TD, ACSI, and Query Store, Resource Governor, SQLDB tips, automation of tasks using runbooks, and if time permits, automation of tasks using Elastic Jobs. So let's start. Integrated authentication. Well, on-premise, we are very used to integrated authentication. We always try to enforce integrated authentication. For what reason we would not try the same on the web? If our server is on the web, we need to use integrated authentication as well. And how do we use integrated authentication with an Azure SQL database? It's simple. We need to set the SQL administrator for the server. The server needs to have a SQL administrator, which is a user from Azure Active Directory. This is essential for integrated security. Once we have this set, so we can use integrated security on our Azure SQL. If we don't set this configuration, we can't use integrated authentication. The screen to set the administrator is this one that you are seeing on my screen, a screenshot. We choose the admin on Azure Active Directory and set that user as an admin. And from this point and onward, we can connect to Azure SQL using an integrated authentication. And integrated authentication in this case, we can use an Azure Active Directory user. Active Directory with Universal MFA and so on. Let's see a demonstration about this feature. Let's see this feature working. I have a simple database here that I created especially for this session, SQLDay server database windows.net. I created especially for this session, but at the moment I'm connected to this database as a SQL user. I'm using SQL user, the SQL user which was created when I provisioned the database. So once I connect the query window, you can see here below that I'm using really a SQL user to connect to this database. Let's connect that. And let's fix this on the configuration of Azure. Let's go to Azure. I have here, let me find where it is. See, I can close these windows. So I have here my Azure SQL database. But this configuration that I talked about is on the server level. So I need to click on the server, take a look on the server level. and Active Directory admin. And here I can set the admin. So you may think, what user would we set as an admin? Who in the company would we choose as an admin for our Azure SQL? That's the point. It's not a good practice to choose a user and put the user as an admin for the server. This is not a good practice at all. It's not something good at all. So what's the option? What can we do instead of that? Instead of that, we can go to Azure Active Directory, create a group, and include the user that we would like to admin this server in that group. So here, as the admin of the server, I can choose the group SQL admins instead of a specific user. So I don't set a specific user as an admin of the server. It would not be a good practice. I set the group as the admin of the server. So I should set admin. Now I save. I'm saving the configuration. Successful. So I set the entire group as the admin of the server. Anytime that I include a user in this group or I remove the user from this group, I will be giving the user the power of an administrator of the SQL Server in the cloud. So now that the SQL Server has an administrator, I can make an integrated connection, an Azure Active Directory integrated connection. Let me use one personal user that I have. So I'm just defining my email account. I'm just giving my email account as the identification of the user and connecting. Let's hope I still remember the password. Yes. So I authenticated with my Microsoft account and I have access to the Azure SQL now using integrated authentication. Now I'm using my Azure account here in order to access my Azure SQL. That's it. Now we prevent any passive communication and so on, and you make a safer authentication using Azure Active Directory. Quick Store on, XCSI on, TD on, and ADR on. So these configurations are default. Okay, interesting. But what's the consequence of these configurations? Let's get back to our PowerPoint and talk more about the consequences of this configuration. TD. The consequence, besides the obvious consequence that is safer, there is a difference on the administration that many of you may not notice. If we manage TD on-premise in an on-premise environment, then we need to manage the keys. We need to create a master key, we need to create a database key in order to enable database for encryption, in order to enable the TDE. But in Azure SQL, the keys are automatically managed by the service. Microsoft manages the keys automatically. Of course, I'm not expecting you to read out this that I copied on this slide. This is only for reference. This slide will be shared later. But what this is saying is that Microsoft manages the keys for you. Even in complex scenarios, for example, when we decide to make a dual application on Azure SQL. So Microsoft will manage in such a way that the secondary node will have the same master key than the primary node. And this will be Microsoft's responsibility. unless you decide to use some different feature like bring your own key. If you need to use a customer key, if you would like to bring a customer key, you can. But it's not the default behavior. The default behavior, it's enabled and Microsoft is managing the key for you. RCSI. Read Committed Snapshot Isolation. What's that? For who? For anyone who had not many contact with RCSI. What's this? This is a database level configuration that changes the isolation level of the database and manage to change the isolation level of the database without any code change on the application. You don't need to change anything on the application. The isolation level will be changed. And the idea of the RCSI is exactly what the name says. Read committed snapshot isolation. What this means? This means that any application that connects to SQL Server using read committed isolation level will be converted to a snapshot isolation level. Of course, I'm not telling the truth. I'm telling half truth. Because the isolation level used by RCSI configuration is not exactly the snapshot isolation level that you can explicitly use in your transaction. It's different. In fact, the isolation level used by RCSI configuration is lighter than the snapshot isolation level that you could use on your transactions. Okay, and why is this important? This is the default isolation level for Azure SQLDB. This changed a lot because on-premise, our database on-premise used by default with committed. It's up to you if you would like to enable RCSI. You can enable RCSI, you should have enabled RCSI, but it's up to you. On Azure SQL, it's the default. It's already enabled. So if you move to Azure SQL, it's already there. And as a result, this is a beautiful result. I love this result. No lock is not useful anymore. Why you would use no lock in an environment that use RCSI? Probably I'm exaggerating a bit. Probably some crazy guy would create a crazy reason to use no lock in this environment. But in general, no lock is not useful anymore. You don't need no lock anymore because you are using a snapshot isolation level. It's not exactly the snapshot isolation level, it's the RCSI. So there is no meaning to keep no lock over Azure SQL database. It's useless. It's absolutely useless. If your application is using no lock over Azure SQL, this is useless. And there is a catch. RCSI and ADR. ADR is the accelerated database recovery. We saw in the options that ADR is enabled as well. ADR is also enabled. But this makes a change to RCSI. How the snapshot isolation levels work? The snapshot isolation levels work keeping a set of system tables called version store. And this version store is kept inside TempDB. It's usually kept inside TempDB unless ADR is enabled. And ADR is enabled on Azure SQL by default. What does this mean? This means that the version store is not in the TempDB. The version store is in database, inside your database. So any queries or any practice that you have to check the version store will work in a different way in Azure SQL, because in Azure SQL the version store is not in TempDB, it's inside the database. Because the set of configurations of SCSI and ADR. Oh, but this is just an Azure SQL difference. No, it works like this. It doesn't mind if it's Azure SQL or if it is on-premise. It works like this. The point is, on Azure SQL, this is the default. And many people moving to Azure SQL may not notice this is the default. Let's see a demonstration about this. So, I'll get back to my SSMS. Now I have demo files to B and to C to make this demonstration. Let's go. Demo 2, demo 2B, and demo 2C. In fact, I exaggerated a bit on the code, but that's it. Let's start with demo 2. On demo 2, I'll begin a transaction and make an update of a customer. I will update this customer. Update middle name. Let's change the middle name to News and make the update. It's done. But I just did that in the middle of a transaction, so it's not completed yet. This transaction can be rolled back or committed, anything can happen. It's not completed yet. As a result of not being completed yet, this means that I have active locks in this database. So I have a lock key. I have one exclusive lock over a record, and I have an intent exclusive over a page. So I have locks over this database, but since I don't have any other activity, I don't have any blocked process. There is no blocked process here. But the point is, the table which received the update is sales LT customer. That's the table. So here on demo 02B, I'm making a query over sales LT customer. The other transaction has an exclusive lock over one customer. One customer was updated, and the other transaction has an exclusive lock over that customer. So what happens when I execute this query? I execute this query and it executes. It simply executes. Just that. It ignores the fact that there is another transaction making an update and the update is still pending. It executes. But what about the data? The customer being updated is the customer 1. Okay, I have the customer 1 here. Customer 1. The query is updating the middle name of the customer 1 to News. And the middle name of the customer 1 is N. What this means? This means that this query that was completely executed is not seeing the updated information. And that's okay. That's okay. This will not see the updated information because the updated was not completed. But what happens is that this query was not blocked by the update. Why people use no lock? Why people love to use no lock in databases and database servers that are used for web application? Because they they believe, they know that if there are a lot of updates, the selection run is lower because the selection needs to wait the updates to be completed until the select is completed. But when I change the isolation level to snapshot isolation, in this case with the RCSI turned on, this doesn't happen. The select doesn't need to wait the update to be completed to retrieve the data. It will just retrieve an old version of the data. Old version of the data. If you are not familiar with the concept of version store, that's when this concept comes in. The version store. For the snapshot isolation to work, the snapshot isolation needs a version store. Usually, by default, this version store is kept in TempDB. However, if I try to create the version store in TempDB, here I will receive nothing. It's completely empty. There is nothing in TempDB version store. Why? Because accelerated database recovery is also enabled. And when RCSI and ADR are enabled, the version store is in database, inside our database, SQLDay data, and not in the TempDB. So the the DMV that we need to use to check the version store is different. Is this different DMV that checks the version store on our own database, our in-database version store, instead of the TempDB version store. So I can select this query, execute, and it will bring me many details about the version store. I will not go so deep on these details because I would end up transforming this session in a 500 level session. But this version store contains information about the transactions that are linked to the version store in the moment. I can even retrieve exactly this information. These scripts will be shared after the session. And as I was saying, I can retrieve exactly this information. I can retrieve what sessions are linked at the moment with the version store. What sessions are using the version store at the moment. And it will tell me that I have an active transaction in session 54, and session 54 is using the version store. So other sessions can execute the select without being blocked. Without being blocked in any way. I always tell everyone, RCSI is the replacement for the terrible no lock. So everyone should stop using no lock and start using RCSI. And they will not have the blocking in production environment. That's great. I can confirm the session ID. We select SPID, and this is the session 54. This is the session 54 that is linked with the in-database version store. Let's make a go back, and this concludes this example. But I can't finish this example without highlighting this one more time. If you migrated to Azure SQL and you are still using no lock in your application, then you are losing the integrity of your data and getting nothing in exchange, because the Azure SQLDB already uses FCSI. The no lock is not needed. Including a no lock in an application with access to Azure SQLDB will only make you lose the integrity of your data. Only that. So, now let's talk a bit about Resource Governor. Resource Governor. Who remember what Resource Governor is? Resource Governor is a SQL Server feature that allows us to control the resources used by each database. Control the memory, the CPU, amount of memory, amount CPU that each database will use in our environment. So, Resource Governor controls this. Why is this important? Well, when you are using an Azure SQLDB, aren't your resources controlled? You are in a level of resources, and your resources are controlled inside that level of resources that you hired. So, your Azure SQLDB runs under Resource Governor. Resource Governor applies to your Azure SQLDB. And why is this important? So, Azure SQL runs under Resource Governor. Resource Governor will throttle resources. So, when the activity in your SQLDB, in your Azure SQLDB, reaches some limits, the Resource Governor will throttle your resources. Why is this important? Because since you know that Resource Governor is active for your Azure SQLDB, you can identify problems using Resource Governor DMVs. There are specific DMVs for Resource Governor that can identify problems in your SQL. This works for on-premise servers using Resource Governor or our Azure SQL database. It's the same for both. So let's see how this works. So here I'll get demo 3. The main point here is a DMV called CDM Resource Governor Workload Groups History X. Resource Governor is based on workload groups, and this DMV keeps the history of the workload groups. This query makes a very intelligent method to discover in what workload group this database is. Because the workload groups inside Azure SQL, they are always called user primary group.db and the ID of the database. So if you have many databases on the same server, how you get the workload group of one database? So this query is making a calculation here and checking if the end piece of this workload group name is the DB ID. If this is the DB ID, then this information is for this database. In this case, I'm summarizing many fields here to identify the recent activity on this server. There are some recent activity on this server. And delta CPU active MS, it means the time the CPU was active doing something. And delta CPU delayed MS means in how many milliseconds the CPU was delayed. And how many times the CPU were delayed. It happened 2 times. Twice. The CPU was delayed twice. It's still getting a recent history because I made some tests about this morning. Because usually in SQL, Azure SQL that you just provision it, this would be all empty or 0. But I can cause a bit more stress on our Azure SQL using the great application SQL Query Stress created by Adam Mechanic. So I can use this application and cause some level of stress to our Azure SQL. Let's see how our Azure SQL replies to this stress, how it reacts to this stress. So I'm using here on the configuration on this application 50 interactions and 50 threads. It means that 50 threads to try to execute something on the server, and each thread will execute a total of 50 interactions on the SQL Server. Let's take a look on the database. SQL database, SQLDay data. Let's make a refresh here on this graph and see how is the activity at this moment. So at this moment, it's not showing the exact moment, but the activity was quite high. This server has NDTUs available, so it's not showing the top activity, is not updated yet, but it's quite high. How is the SQL stress? SQL stress finished, and it seems it went beyond 50% of the DTUs. With 5 DTUs, it would have reached 100%. I made the test. This example with 5 DTUs would have reached 100%. But with 10 DTUs, it was just a bit above 50%. So I may see some additional numbers on time of CPU active. But resource governor really throttled the CPU at some moments. The queries were really throttled at some moments. Maybe not in relation to CPU. No, it's in relation to CPU because there is the delay on the CPU. And I'm not even checking other counters like memory, for example. Of course, these queries are only a simple example. The point is knowing that Azure SQL is linked to Resource Governor enable us to execute some queries to analyze how is the performance of Azure SQL and if Resource Governor is in some way affecting our Azure SQL. And if it is, it may be time to make a scale up of our Azure SQL in case of Resource Governor is affecting our Azure SQL. But it depends. There are many things to check. So, getting back to the PowerPoint a bit, then we have SQLDay tips. What's this? This is a set of scripts available on GitHub, and they execute many tests on Azure SQL database and provide suggestions and guidance about what to do with our Azure SQL database. What should we do to improve our Azure SQL database? And it's great, not only because it's a ready-to-use script that you can get and execute on your Azure SQL, but because from this script you can analyze the system tables where this script is getting the data and studying more details. How can you monitor your Azure SQL? So this is great. This is the GitHub address for this script, this set of scripts. And let's see they working. Let's see an example. I have them here, demo 4. So I just need to execute. These are ready to use scripts that we can get from GitHub. It takes some seconds to run. And here it is. It identified some problems. It identified some problems on my Azure SQL. I'm using SQL Query Stress over it. I already used it sometime. It found throttling caused by Resource Governor. It found possibilities for compression, suggesting compression. It found impact on I/O, workload I/O governance, and so simply by running this script over our Azure SQL, we already discover many details that we should be checking. But analyzing the script in details, we'll learn more about how to monitor our Azure SQL. So this is a great script, really very good script. Okay, let's go ahead and then let's talk about automation. What I'm talking about automation? Well, it's something so natural on premise that we barely think too much about it in the cloud. On premise we have SQL agent. We have SQL agent and we create jobs inside SQL agent. That's absolutely great. It works. It's great. That's absolutely great. The problem is that using Azure SQL database, we don't have SQL agent available. So how will we automate tasks in the cloud environment if we don't have SQL agent available? So we have more than one option. Let's start talking about the first one. So automation, there is no SQL agent, and the first option that we have is to use what is called an automation account. This is not a feature made only for SQL Server. An automation account is an automation feature that can be used across the entire Azure environment. for any Azure task. I'm used to say that an automation account is one of the Azure services that is so basic and so needed for everything. That is one of the basic services that we need to configure and plan when we are starting to move to the cloud. We need an automation account. It's one of the very basic services that we need. And inside the automation account, we create runbooks on the automation account. These runbooks will be created in PowerShell or Python. Yeah, that's it. To automate tasks in SQL Server, you will need to use PowerShell or Python. That's your choice. You can choose one. I prefer PowerShell, but it's up to you. You can choose between PowerShell or Python to make the automation. And then you schedule the runbook execution. So this is the automation account, the provisioning of the automation account. And when we create a runbook, we have these options. We can use PowerShell, Python version 2, Python version 3, graphical design, there is a graphical design, PowerShell workflow or graphical PowerShell workflow. So we have all these options to choose to create a runbook. Then we define a schedule for our runbook. We define how often our runbook will execute and we link everything. We link the schedule with the runbook. And I'm simplifying, but we will see a demo about that. Some secrets about this. We can't forget to publish our runbook. When we build the runbook, we need to publish it before configuring the schedule and the execution. If the runbook is not published, everything else is disabled. And the workflow in the runbook needs to have the same name as the object. You'll see this happening in a few minutes. Let's see a demonstration about this. To make the demonstration easier, to make it easier to make a demo for this, I already provisioned a runbook here. A runbook, no, sorry, an automation account. I provisioned an automation account. When we provision an automation account, the automation account is provisioned with 3 demo runbooks. So we have these 3 demo runbooks that we can analyze and see how the runbook works. But that's not what I will do. Let's get into the automation account and start configuring the details. One important detail here is the credential. I need to specify the credential that my runbook will use to access SQL Server. By default, this credential is a SQL user. Yes, I use this default to simplify the demonstration. Is it possible to use an Azure Active Directory user? Yes. Not on the credential, but we can customize the runbook code to use an Azure Active Directory user, but not here. And let's make this simple for now to take way longer to make a demo with Azure Active Directory. So I'm defining my SQL user in the credential. So my credential is called SQL user, and runbooks inside this automation account will be able to use this SQL user. So I'm creating this credential SQL user. Great. Credential created. Now, let's get back to overview. And here I have the list of runbooks. I have the 3 demo runbooks, a graphical one, a Python one, and a PowerShell one. I can create my own runbook, but I will make better. I will browse the gallery. Yes, Azure has a gallery of runbooks ready to use. And it's checking the GitHub and by popularity, by the type of runbook, and so on. From Microsoft, from community, and so on. And for SQL, this is for Azure in general. So many of these runbooks are for activities in Azure that are not related to SQL Server. This is for Azure in general. But in relation to SQL Server, there is one runbook for indexing. Let me find it here. Index tables in Azure database if they have a high fragmentation. And this is interesting because the code of this runbook checks for the fragmentation and only re-index the indexes if they have a high fragmentation. So I'll choose this runbook. And this runbook is a template from the gallery, and I need to import this runbook. So import it. I'll give a name for this runbook. SQL indexing. And okay. So done. The runbook is imported. I keep on the same screen, but I can get back. Make a refresh here. And we can see SQL indexing our runbook. So I'll get into this runbook that I just created. And there is the entire PowerShell code inside this runbook. If I edit, I can see the code and analyze the PowerShell code that will be executed to this runbook. And the runbook I created is called SQL indexing. Okay, so it was complaining about bad sound, but I think it's got back, right? I think everyone is hearing me now. So let's continue. So my runbook is SQL indexing, and there is a secret here. I mentioned this. The secret is that the workflow needs to have the same name as the runbook. The workflow needs to have the same name as the runbook. So I need to rename this workflow, and this workflow needs to be named SQL indexing. If I don't make this change, changing the name of the workflow of this runbook to the same name of the runbook, I'm not able to publish it. I can't publish this runbook. And if I can't publish, I can't activate it. So, publish. So now my runbook is published. And I can just start. Let's just start. I will not make a schedule now, but I will start the execution of the runbook. Let's test the runbook. So I have here my database. I have here my database, and I will copy the URL of my database and use the URL of my database on SQL Server. Database name is SQLDay data. Credential name, the name of the credential I created, SQL user. And there are some additional parameters. These parameters they are defined on the PowerShell. The PowerShell script requires these parameters to go forward. So I have fragment percentage, how much the table, the index needs to be fragmented to be indexed. It uses the full 20%. SQL Server ports, rebuild offline, no, I will build online, table, if I would like to focus in a single table, no, I'll click OK. So I'm executing the runbook. Let's just wait a bit and make some refresh. While it's executing, it's interesting to note that the automation account and the runbooks are one of the options to make automation for Azure SQL. There is another option, a second option. The other option to make automation for Azure SQL is called Elastic Jobs. While the runbook is executing, let's talk a bit about the Elastic Jobs. This is a solution only for SQL Server. While the automation account is made for the entire Azure environment, we can make automation for all the Azure services. Elastic Jobs is a solution for only SQL Server. It was originally designed for sharding scenarios. What is sharding scenarios? We're talking about Elastic database pools. We are talking about scenarios, for example, where we are providing a software as a service scenario. We have 10 clients and we break down the data of each client in a different database. The scheme of the database are usually the same, but each client that has our company, we put in a different database. And we manage this database as a single set of database. It's a sharding scenario, one possible sharding scenario. But we can use Elastic Jobs to make tasks for a single database. There is no problem. It's perfectly possible to use Elastic Jobs for a single database. So one option for automated tasks is automation accounts and runbooks. The other option for automated tasks using Azure SQL are the Elastic Jobs. We have these two possibilities to automate tasks for Azure SQL. Let's take a look on Azure again. It's completed. So the runbook was executed and was executed successfully. Input. No, there were errors. There were some errors indexing the table. I will need to check later why the PowerShell script failed on indexing our tables. It failed the index on the tables. This is not usual. I will check later. I'll post a message later about that. Unfortunately, we will not have enough time to talk deeper about Elastic Jobs, but I will summarize the content. I already mentioned this. And the steps to build a job. We create an object in Azure called Elastic Job Agent. This Elastic Job Agent will manage the Elastic Jobs. Then we need to create authentications inside the database for the connection of the Elastic Jobs. When we create an Elastic Job Agent, the Elastic Job Agent asks for a job database. That database will be used to manage the jobs. And we create a target group for the execution. You will see the details. The last job was planned not to be executed over one database. It was planned to have jobs to be executed in multiple databases. So we have a concept to have a target group. Then we include members on this target group. And then the jobs will focus on the target group. The jobs will be executed on the target group to many servers at once. Then we create a job and include the steps on the job. And finally, we define the schedule for the job. All these steps are made, except the first one, which is on Azure when you create the object. All the other steps are made in SQL. We make all these steps in SQL, creating the credential, creating the target group, and so on. And the scripts to create this are available here. The scripts to create the credentials, I just didn't include the password. The scripts to create the target groups and include members on the target group, include the server as a member on the target group. The script to create a job and schedule the job. The last one is to drop everything. Is to drop, disable and drop everything. So these scripts are available. I will publish these scripts to gather the content of the presentation. So, thank you very much for attending this presentation. I hope you liked the presentation. I hope you learned something new on the presentation, something new about the administration of Azure SQL that you can use on your work. Thank you very much for attending this presentation. Any questions? No? Thank you very much.